when we're looking at trigonometry or trig, and we're looking at our trig functions, our basic trig functions that we're going to be responsible for knowing this year. Those are going to be our sine, our cosine, and our tangent. So we need to know our sine, our cosine, and our tangent. And really all that is some sort of combination of what the sides look like in terms of the angle. So if we're looking here, we can see that all three of these triangles have the same angle that we're referring to. And we're going to call that theta, which is really just a circle with a line going through it. So theta is our variable that we use to represent what angle we're actually looking at. Because depending what angle we're looking at, the sine, the cosine, the tangent are going to change. With these relationships, the sine of a triangle or the sine of a angle is always going to be the opposite side over the hypotenuse side, and we get this term called SOH, which is SOH. S stands for sine, so you have sine of theta is equal to O is opposite, the opposite over the H, which is the hypotenuse. When we talk about it, the opposite side of the angle is the side that is directly across from theta. The hypotenuse is the side that's going to be across from our 90-degree angle. And this last side would be called our adjacent side. We're going to see that in about 2 seconds. So, for when we're talking about sine, all we're worried about is the opposite over the hypotenuse. We need to know what the angle is, find the opposite side, find the hypotenuse, and we can create a sine relationship. The next function we'll need to know is cosine. Cosine now is going to be the adjacent over the hypotenuse. So if I'm looking at the same exact triangle, if I'm looking at this same measure, this degree, or this angle, my cosine is going to be my adjacent over my hypotenuse. So my cosine of theta is going to be my adjacent over my hypotenuse. My adjacent side is going to be the side right next to theta, and obviously the side that is not the hypotenuse. So my adjacent side is going to be next to it. My hypotenuse is still across from my 90-degree angle. So if I were to set this up, I could say it's my adjacent over my hypotenuse. Cosine is represented by ca, C-A-H. The C stands for cosine, the A stands for adjacent, the H stands for hypotenuse. And then the last one, if we haven't put it together yet, is going to be my tangent. And tangent is always going to be opposite over adjacent. So for the tangent of theta, I'm going to look at the opposite side, which is across from that angle. So it's going to be the opposite side over the adjacent side, which is going to be the side right next to that angle, the side that is not the hypotenuse. So we've got sine, cosine, and tangent. And tangent is, we refer to that as TOA, which is tangent, opposite, adjacent. And you'll see this written plenty of times. So, ca, TOA. And that's just a good way to remember my trig functions and which sides they relate to. So, TOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA is tangent over, tangent is opposite over adjacent. That's how we can relate it, by remembering SOHCAHTOA. Now if we look at a triangle, and it's got to be a right triangle, if we look at a triangle, we can set up the three different trig functions. Now remember, I'm setting these up with regards to whatever angle that I'm looking at. So if I'm looking at the sine of theta, that means I'm looking at this angle here. This is my theta angle. Remember, sine is equal to opposite over hypotenuse. So, SOH, sine opposite hypotenuse. If I want to set this up, I want to find what the sine of this angle is. The sine of this angle is going to be the opposite over the hypotenuse. So we could just write that as B over C. And it's going to be that simple. If I want to find the cosine of theta, cosine is equal to, remember it's ca, C-A-H, so it's cosine is equal to the adjacent over the hypotenuse. So if I'm looking at theta, my adjacent side is A, my hypotenuse is C. So this one would just be A over C. And my tangent of theta, tangent is TOA, opposite over adjacent. My tangent of theta, I could write as, let's get that out of there. I could write it as opposite, which is B, over adjacent, which is A. So my tangent would be equal to B over A. So the most important thing is understanding what angle it is we're looking at, and then we can actually set up the sides. Now we can use these relationships to solve. If I've got a degree measure and I have a side length and I'm looking for another side length, I can set that up. Obviously here I'm going to be looking at my 55-degree angle. So that's going to be my theta is this angle E. I know that I have the adjacent side here, and I'm looking to try and find my hypotenuse. So if I have an angle, I have the adjacent and I have the hypotenuse. Adjacent and hypotenuse, remember we said cosine is adjacent over hypotenuse. So we can set this up. We can say that the cosine of 55 degrees is equal to adjacent, which is 4 over x. Now that's just my setup. Now to solve this, I've just got to use a little bit of algebra. So I want to solve for x here. What we can do whenever our x or our missing value is in the denominator, we can set this over 1 and we can cross multiply. So I can say that 4 times 1 is 4. That's going to be equal to x times the cosine of 55 degrees. To get x alone, I just have to divide by the cosine of 55 and divide by the cosine of 55. If I write that up here now, I will have x is going to be equal to 4 divided by the cosine of 55. And that's good for me. We could go through and work that out. We could do 4 divided by cosine of 55. Just make sure our calculator is in degree mode, and you'll be able to find an actual measure there for x, which is, remember, the hypotenuse. Now looking at the second problem we have here. I've got another right triangle, so I know I can use my trig. I have an angle. I have the adjacent, and I'm looking for the opposite. If I have the adjacent and the opposite, remember tangent relates the opposite to the adjacent. So I can say that the tangent of 37 is going to be equal to my opposite, which I don't know, over my adjacent, which is 3. Now these ones are going to be easier to solve for x. To solve for x, multiply the right side by 3, get rid of that. Anything I do on one side, I got to do on the other. Tells me that my x is going to be equal to 3 times the tangent of 37. Again, you can plug that into your calculator, make sure your calculator's in degree mode, and that'll just spit out an answer for you. And that'll be the missing side that we were looking for here. So we can set up these equations, we can solve these equations, we can find missing side lengths. What we can also do, if we use our inverse trig, is we can find what our angle measures would be. So I've got z and I have y here. We're going to start with z. If I'm trying to find z, this angle here, I know I have the opposite and I have the adjacent. So I can set up, using tangent, I can set up to solve this. So I'm going to say that the tangent of angle z is going to be equal to the opposite over the adjacent. Now we notice this one we're not missing a side length, we're missing the degree. To solve for our degree, we're going to find the inverse of tangent, or we're going to find the arctangent. And now most calculators will have the inverse button represented like this. It'll say tangent of -1. And if we want to solve this, all we have to do is put our relationship inside of the inverse side there. So we've got our tangent of -1 of 33 over 56. Now, of course, you could do the same exact thing there. We plug that in, and you're going to get that. What you could also do if you don't have an inverse and you only have a tangent button, that means that z is going to be the same as 1 over the tangent of 33 over 56. And if I actually go ahead and plug that into my calculator, I find that the inverse of tangent of 33 over 56 is going to give me about 30.5 degrees. So that's what my z is going to be in degrees. Now there's two different ways that I can find y now. I could go through that same relationship and I could say this is my new angle, this is my new opposite, this is my new adjacent, and I could set up tangent. Or I could use the properties I know about triangles, that all three angles need to add up to 180 degrees. And I can say that I know that I have a 90-degree angle in there, and I know I have a 30.5 degree angle. If I subtract 180 minus 90 minus 30.5, I'm going to get that y is equal to 59.5 degrees. So there's a couple ways that you could do that, but I wouldn't be able to do any of this if it weren't for my trig relationships.